Alrighty. Before we zip into lesson 7, I just want to show you again what our schedule is looking like so that we are on the same page and a chance to ask questions that we have. We know today's a half day. It's the end of marking period 3. Scores are set in the grade book and great success all around our whole class. So I'm feeling really, really good about that. I still have a few students who need to make up their Unit 3 test. So my goal is to get those back to you on Monday so you can get that feedback on Monday because I still have some students who are taking that. All right. Our optional SAT sessions after school are Monday, Wednesday, and Thursday. If you're interested in those, feel free to stop on by. We have a pretty good time, I gotta say. We have some good laughs and people are definitely seeing some familiar problems from the units we've covered so far in Algebra 2. More practice builds more confidence, and that's really our main goal. If you can go into that SAT knowing what to expect, you're going to feel so much better about what you're walking into, right? It's a high stress. It could be very high stress, but with a little bit of practice and prep, you're more ready for it. Remember, too, there are student guides for it in that reception office. Right? So what I have is a practice written, is on paper, just like your SAT would be. But the guide that they have in the reception office is available for both the SAT and the PSAT 10. So either one that you're taking is good to have. And they have lots of information about how the test works, so you're familiar with the setup and the schedule for it, as well as some practice questions and some ideas about how you can prepare. So it's a good thing to pick up. Juniors, on Tuesday, you will pre-bubble. It does take an hour and more to pre-bubble your SAT score sheets. So on that day, you will go according to your last name to the cafeteria. They will call you down during different blocks throughout the day. All right. So our juniors, that schedule is, if your last name starts with A through G, you will go during block 1. I'll remind you on Monday too about this, but go to your block 1 class, take attendance, check in with your teacher, see what you're missing, then head down to do the pre-bubbling. They should call you down over the announcements at the beginning of block 1. Block 2, this block, if your last name starts with H through O, you'll be going down during block 2. I'll be recording the lesson that we're having that day and putting it up on Google Classroom so you can catch back up. Again, come here first, check in with me, take attendance so I know that you're here so I can mark you as present. And then P through Z will be during block 3. Yeah. It's are you at CTC? Okay. You should be school related from that. Do whatever you need to so that just like a normal block, you would be counted present for attendance. But you'll need to organize so that you can be here in the cafeteria. And you can't switch to a different block because they've got it set up by alphabet with all the things that we need. Yeah. So you'll need to arrange with your internship, if that's what you're doing, that you would need to be here that day to do that block time, that pre-bubble. It will likely take a lot of patience on the part of our juniors. Please be patient with our counselors. They're going to have 70 to 80 students in the cafeteria, and everybody's pre-bubbling. I mean, they're going to ask you so many questions for this SAT pre-bubble. They want to know all the classes that you've taken, what clubs or activities and sports you're in. They want to know your age, your ethnicity, your race, your all the classes that you've taken, your address, your zip code, your phone number, your parents' number, your email address, what colleges you want to go to, who they should share your scores with. I mean, they're going to ask you so many questions. And then you have a second answer sheet that you'll have to do for the work keys test. Not as question heavy, but still pre-bubbling things like your name, your address, your phone number, your student ID number. We have a high school code, all kinds of stuff like that. Okay. It will take more than an hour to do it, definitely. So be ready with all the information that they might be asking for, and be patient with the counselors because they'll be zipping around to all these different people to help them out with questions that they have. If you cannot be here on the 30th for pre-bubbling, you cannot take the SAT on the 13th and 14th. If you're going to a college that requires the SAT, that means you'll have to find that makeup time. We do have a makeup date later in April. You'll still have to figure out with your counselor when you can pre-bubble everything. So know that if you can't be here for pre-bubbling, you will have at-home work on the 13th and 14th. We can't have you even coming to school because we have everybody scheduled all around the whole school and nowhere for you to be. So, pretty big deal. Be here. We have a quiz on our lessons 1 through 6. I mentioned that it would be next week. We're looking at Wednesday, and then a half day Friday, and then spring break. Please remember too, our scheduling portal closes on the 16th. You should be listening to announcements carefully. They're having interviews for things like PALs coming up by invite only. They're having auditions today for all of our choir classes after school. We have other classes that you need to audition for, or test into, or get teacher recommendation or permission to register for. Listen carefully for the announcements for that, or check the website. Right. Any questions for me about pre-bubble, about quiz, about scheduling portal? Emma.
So then we're not allowed to take it the 13th and 14th. Is there like another date they have decided for the people that are taking it those days?
The makeup date that they have, it's always 2 weeks after when we give it. So 13th and 14th. 2 weeks after 13 and 14, let me get to April, would be the 27th and 28th. But you'll still have to arrange with your counselor about when you can pre-bubble those, because you'll still have to have your answer key pre-bubbled. So yep, the 27th and 28th is when you would have your makeup date. Any other questions? All right, nice. Thank you guys for that wonderful conversation. I appreciate that we can work through our schedule and keep ourselves reminded about what it is that we are looking for. If I remember correctly, we have already started 7.2, which puts us in a fantastic place. We were looking at things like how we could use radiocarbon dating. And if we know how much of an element we start with, a half-life is telling us that the rate is cutting it in half. And our exponent is going to be based on how many cycles or what portion of a cycle of 5,730 years that it has been through. And we ran our calculation using that formula. If we had something that started with 3 picograms, had a half-life, and we gave it 1,910 years out of the full half-life of 5,730 years, we figured out it would have 2.38 picograms left in that point. So that's right where we left off. We've got this next question, though, this next blank about, well, how many years if we measure it and find 0.75 picograms left? So this time we're going to use our equation that we have. We started with 3 picograms. We have a half-life going on. But we don't know how many half-lives it has been through. to equal 0.75 picograms. Is there a pattern that we can notice about what is happening with our amount of picograms? We definitely know it's going to be more than one full half-life because we have less material than we had at one full half-life at 1.5. So cutting it in half from 3 to 1.5 picograms was one full half-life. Is 0.75 half of 1.5? I'm wondering if it just has us going through a whole new half-life going on. Oh, that's pretty awesome. So cutting it in half again from 1.5 to 1.75, if the material is cut in half, it has gone through a full half-life cycle. We've lost half of the material. So we can think of it as up here we started with 3 picograms. By here it has been cut in half to 1.5 picograms. And then again we've cut that part in half to be 0.75 picograms. It's gone through a whole nother half-life. So this difference means that we have gone through a full half-life cycle. And I realize how many times I'm saying things like half-life. This idea, it's weird to say words like, it's a full half-life. And you're like, wait, is it full or is it half? We think about that full cycle that it takes for it to accomplish cutting itself in half. That means it has taken an additional 5,730 years to get there. And this means we are looking at, oh my goodness, year 11,460. Whoa. We can work through our equation that we wrote here using the amazing math skills that we have. All kinds of good stuff sharing my screen. So if we had divided both sides by 3, 1/2 to the I don't know what power equals 0.25, or 1/4. Oop, I wrote a 2 instead of a question mark. And I could find out, I could do some guessing and checking, or we'll find out later in our unit how also we could solve that with a new skill. We would find out that it has gone through 2 half-life cycles. Now this is stuff that's like mega years of dating. So when we're talking about this kind of half-life cycle, we're not talking about, hey, was that document that someone made 10 years ago real? We're instead talking about like, hey, is that original copy of that Roman manuscript actually accurate? All right, so we're talking like ancient times. We can also look at things like fossils, which is what this is looking at. So if you're thinking of working for a museum and being a curator for a museum, you'll need some of this kind of stuff to date stuff and be able to tell if something is accurate or if someone's trying to pull your leg. You don't want to spend millions of dollars for some museum and have it be a fake. That could be really bad. That's when people lose their jobs. So a scientist uses that same expression with 2.5 times 1/2 raised to the T over 5,730 to model the number of picograms of carbon-14 remaining. What do the 2, the 1/2, and the 7 of 5,730 mean in this situation? Let's see if you guys can tell me this stuff, because it's very similar to the equation we wrote on the previous page. Salvador, what do you think that 2.5 is representing? Gotcha.
He's coming off guard.
That's okay. Yep. So that scientist, he's written this whole equation to model some information. And we're thinking about what we know about our box times box raised up to an exponent box kind of thing. We're also looking back at our equation that we wrote for this same kind of situation. So using maybe this idea from your previous page in our equation here, what usually goes in our first box when we are writing an exponential equation? Nice. Our starting value is telling us how much we are beginning with. So here we started with 3 picograms, so we wrote an equation with a 3 picogram in it. This one is starting with a 2.5, so there's our starting amount. So the 2.5 is the starting amount. Cade, what do you think that 1/2 is representing in this same equation? Nice, wonderful. It's our growth factor. If we are using a half-life, all half-life problems will use 1/2 as their growth factor, because that's exactly our idea. It's cutting the amount in half. Kennedy, where did they get the number 5,730 from?
So that's like the cycle. So like in the previous one, it says that it loses half of it every this amount of years. So that's the amount of years of the cycle.
All right, nice. So it's the cycle or the number of years for a half-life. Nice. So 2 great ways to think about it. It's the cycle. How long is one full cycle? What is the number of years for a half-life to happen? Different elements have different half-lives. So if we're looking for something that is really ancient, carbon-14 makes sense because we're looking at almost 6,000 years. If we're looking to date something, maybe from like the Constitution to see if it's an original copy of our Constitution or the Declaration of Independence, we might choose a different element that has a shorter half-life because that's just awfully long for something that was only 200 years ago. So let's see what part B is asking us now to use this equation. Would more or less than 0.1 picogram of carbon-14 remain in this fossil today? All right. Well, if T is our number of years, that's the only thing that we don't know, and we need to figure out how long it would be. T years after 2000 BC. So our historical timeline. 2000 BC. Then we had 0. And right now we are in 2021. So from 2000 BC all the way up to 2021 is 22,000 22,000 21 years of time. So there's our 2021 plus the 20,000 we would have to go back in time for the BC. Let's see what we would wind up with if we had, starting with 2.5 picograms, growth factor of 1/2, and we let it sit there for 22,021 years out of a 5,730 year cycle. Man, are we getting really great with using our calculators and putting those exponents in parentheses to make it happen. I'll ask Jacob for his answer, and then we'll check with Justin to see if he agrees too, because I want to make sure you guys are using your calculators and getting to the successful place.
0.17.
All right. Justin, did you get to that same answer?
Yeah.
All right. Nice. So 0.17, finding our answer, that's how much of our picograms are left after that many years. I mean, holy cow, 22,000 years. I'm having trouble wrapping my brain around that. So when it asks if we have more or less than 1 picogram, we do have more, just slightly more. So more than 0.1. Stellar. All right. So we can use this kind of stuff, as we've mentioned, about how to date stuff. In fact, Pythagoras, who is a real guy, who lived way back 600 BCE and 500 BCE. We're not quite sure exactly when he lived, but somewhere in that 100-year stretch. Pythagoras is, of course, the guy who wrote our Pythagorean theorem, along with many other mathy formulas and ideas and concepts that were incredibly helpful. He wrote on stuff called papyrus. Have you seen what papyrus looks like? No? Oh my gosh. I love like ancient Egyptian stuff. I don't know why, but I love it. So papyrus starts as plants that they then make into paper. What is that? I don't know what that is. That's not papyrus. Let's put that word paper after it. Now we're going to see papyrus. So it starts as a plant-based, and it's kind of like a woven plant material that they found works really nicely for, if you get it very thin, it works really nicely for paper. And then you can roll it up like scrolls. And so we can look at really ancient documents like this. And this is the kind of condition that they might be in now, to start trying to see how things were written a very, very long time ago. Check that out. Man, I feel like I need to look at this one. It says math in the title. That is so awesome. Look at that. I want to try to read it. I won't be able to, it's all. But look at that. They're doing like math calculations. Look at triangles are all over there. Holy cow, that's so cool. Yipes, that's large. Yipes, that's another pop-up. So we can take a small piece of this papyrus and test it out to see exactly how old it is. And you can imagine that, of course, since it's a natural element made from plants, that it would have some of our elements in it, like carbon-14. So if he lived at this time, the age of papyrus from the time of Pythagoras is about half of a carbon-14 half-life. We're trying to get that explanation as to why. So if he lived, let's say, at 600 BCE, plus we are in 2021 AD, we're looking at about 2,621 years of time. So since Pythagoras lived, we've had about 2,621 years have passed. And when we compare that, 26,021 to the half-life of carbon-14, (5,730 years that we would be taking it. When we do that comparison, you can already see that it's going to be about half of my, look at that, about 4.5, 0.45. Let's round that to 0.46. So comparing 2,621 to the half-life length of 5,730, that ratio is 0.46, which is about half. So if we had someone who is claiming they have this papyrus scroll written by Pythagoras himself, mathematicians pay close attention to that stuff. We're like, ooh, something new, something different. They test and they show that it has 85% of its original amount of carbon-14 remaining. So if it has 85% of its original amount of carbon-14 remaining, that's telling us that it has kept 0.85 of what it started with. So that growth factor, they don't tell us how much we started with. They don't tell us how much we have. All we know is that it's 85% or 0.85 is the growth factor that we're looking for. We have looked at growth factor and how we can change that in our past. It has come up a couple times where we've been able to find growth factors between 2 points as we change the amount of time we've given it to make it happen. If we have this sense that we should be testing it, let's say they came forward this year, we know that it should have about half of its half-life done. So let's just start off with something like 100 picograms of carbon-14. And I'm going to put this little reminder in here, like we just made this up. And I picked 100 because I'm thinking, like, if we start with 100% of whatever we began with, 100% of our amount, if we're looking at percentages of what we're going to be coming up with, let's start with 100% of what we have. Let's run it through our half-life cycle of 2,621 years out of 5,730. We also already know that that's like raised to the 0.46 power because we already did that division up here. So those two things are meaning the same in our exponent. But we could also keep it super, super exact. I'm going to raise it up to the 2621 divided by 5730 power. And so when we have our result, it's telling us we have 72.83-ish remaining. So if we started with 100% of that, we have 72% of it remaining is what we should have if it was really made back in Pythagoras' time. This is what percent we would have left. If it were real. So if Pythagoras really wrote that, we should have 72.8% of our carbon-14 left. This person's document has 85. It's got too much of it left. It's not that old. It hasn't had this much time to decay to this lower amount. So instead, it's much too new. So 85% is too new. It still has too much of its carbon-14 compared to what it should have if it really were authentic. So our half-lives can help us with carbon dating. They can help us with ancient documents. They can help us with what we've already seen too with ideas of medicine in the body. It's like that same kind of idea. If we know how fast something decays or is absorbed or changes, we can estimate just how old it is or how long it's been there based on that info. Lesson 7 summary, just a nice job of looking at a different kind of half-life. So we mentioned that different elements have different half-life values. Sodium-22 has a half-life of just 3 years. So sodium is just a type of salt. So this is a certain type of salt that would decay. So we can see how much salt is left in an object or an item. Or like if we were trying to date some mastodon that someone found in their backyard, we could tell if it was real or if it was fake. If it still has so much of its sodium in, we know that they just buried it in their backyard 5 years ago and tried to age it. So it's kind of a neat one to look at. Will you please get ready to look at our lessons 5 and 6 practice problems? We're going to do that next. Hey, this is Susan. Yes. Yes, I will get into that. Okay, sure. Sorry about that, friends. It's a perfect time for us to stop and take a look at lessons 5 and 6 practice problems. We've got just the right amount of time, so we're not going to even start on lesson 8 today. We use the rest of our time. We've got a good solid 10 minutes to go. What I'd like to do, instead of pulling out our Jamboards and going up here, I would like to put the answer keys up for you on the screen, a chance for you to check your work for lessons 5 and 6. And then we'll see what questions you guys have that you'd like to do together. Once you see the answer, if you're like, ooh, I didn't get that, check with a neighbor, see if they can help you out with how we would have gotten to that answer. And we will then see what questions you have from practice problems 5 and 6. So this will help us a little bit faster. All right. So I will pull up those answer keys, and I'll ask you to check. We'll see what questions you have.